Good afternoon, everybody. Good afternoon. This is going to be an exceptionally exciting session of four really good speakers and me making everybody else look even better by being slightly rubbish. I'm going to get off stage very quickly. I will be appearing every so often to ask questions. If you have questions for me to ask the speakers, then please tweet them under the Next 12 hashtag and I will find them there. To start off with, I'm extremely proud, extremely excited to introduce two people from a company that blows my mind every single year with their amazing robotics and amazing flying creatures and all of that stuff. Ladies and gentlemen, Hildebrandt and Elias Knubben from Festo.
So that's fine. So hello, thank you very much for your invitation. It's a pleasure for us to give this talk about human-machine cooperation. And now just wait for my presentation here. So, sorry, we had the presentation 5 minutes ago here on the screen. So now I need this, please. That's okay. So I can see it here already. Hopefully you get it too. So maybe, okay, so thank you very much. So I will start. So let me say some words about the company we are working for first. Festo is a family-owned company with around about 15,600 employees worldwide, and we are developing and selling products in the field of factory and process automation. Motion control, processing and measuring are our main competences, and our products are used in many branches in the production and assembling process. Besides this, Festo is the world's #1 education and training partner for industry and universities. Therefore, we have developed a wide range of learning systems, concepts, and systems. In 2006, we have developed the so-called Bionic Learning Network, which is a cooperation between Festo and universities, institutes, and development companies. The future concepts of the Bionic Learning Network serve as development platforms that combine a wide diversity of technologies and components, from manufacturing concepts via serious products, up to software and control to regulation technology. So in the last years, many demonstrators came out of it. Topics like lightweight construction, adaptivity, autonomous behavior, and so on were reviewed in this project. But today we want to focus on our new projects regarding human-machine cooperation. So the Exohand and the Bionic Handling Assistant are examples of how structural flexibility and new control concepts can help humans to interact simply and above all safely with human machinery in the factory and the domestic environment of the future. In the event of a collision with a human operator, these systems no longer present a hazard and do not need to be carefully shielded from humans, as in the case of a conventional factory robot. In view of technologies that are coming into increasingly close contact with humans, along with demographic change and the ongoing mechanization of our everyday lives, this hazard-free operation opens up new perspectives for the research field of the human-machine cooperation. The Exohand is an exoskeleton that can be worn like a glove. is customized to fit the hand of the individual user and is manufactured from polyamide in the selective laser sintering process. For this purpose, the exoskeleton is produced on the basis of a 3D scan of the user's hand. The exoskeletal hand has all the principal physiological degrees of freedom of its human counterpart. It thus supports the human hand's diverse techniques for grasping and handling objects. The fingers can be actively moved and their strength amplified. The 8 double-acting pneumatic actors that are attached to the structure of the exoskeleton allow the wearer to open and to close the fingers. The index finger can also be pivoted to either side, and the thumb can be rotated toward the palm, just like its human model. Since all the joints and the drive units are located outside the actual hand in the form of an exoskeleton, this manual orthosis can be fitted not only over the human hand, but also over an artificial hand made of silicon. Using the same hardware, this enables a scenario that creates a link between robotics and orthotics in a completely new way. So there are a lot of applications where this exohand could be used. If, for example, a robot is to maintain its orientation in an everyday domestic environment in combination with the exohand and interact with humans in a variety of everyday situations, the human-like characteristics of the robot will be essential. The 8 pneumatic actors make for precise movement, while at the same time lending the exohand excellent properties in terms of yielding capacity, and thus also for safety. The lightweight construction, the robustness, and the powerful actuators do best fit in the field of service robotics. Despite the high degree of automation in industry, there are still a large number of activities in assembly that can only be performed by the human operator. These include numerous repetitive tasks that easily lead to fatigue. This type of activity represents a challenge, especially to older workers. In most industrialized countries, the average age of the workforce will continue to rise over the coming years. Now, the exohand thus represents a technical solution for the future that meets the challenge of demographic change in the world of production. In this case, the system amplifies the strength of the human hand and could help the employees in the future to remain in the work process for a longer time without suffering permanent physical effects. So the force, we can agree, is around about 20 to 40%. When the exohand is used for remote manipulation of a robotic hand in an industrial setting, complex tasks in dangerous or hazardous environments, for example, can be performed from a safe distance. As a force feedback system, the artificial hand can greatly extend the human operator's scope of activity in a production environment. In this scenario, the exohand is fitted over both the human hand and an artificial hand of silicone. It thus simultaneously functions both as the operator interface and the robotic hand. This allows forces to be transferred from a different environment to the operator's own hand in the form of force feedback. The operator has the sensation of feeling the shape of the remote object. You could also see this if you are interested in a live demo later on in the hall. In rehabilitation, the exohand can also be used as an active manual orthosis. In Germany alone, some 150,000 people annually suffer a stroke for the first time. Many of these patients must learn to use their hands once more. Together with a brain-computer interface, the exohand allows a closed feedback loop to be established. The active manual orthosis can help stroke patients suffering from paralysis to regenerate the damaged connection from the brain to the hand. The stroke patient's wish to open or close the hand is recorded by means of an electroencephalographic signal that is measured on the subject's hand. The movements are carried out by the active manual orthosis. This gives rise to a draining effect, which over the course of time enables patients to move their hands once more without technical assistance. So this is our demonstrator, which we have presented the first time this year in April at the Hanover Fair. As I said, we want to invite you to see this live afterwards. So there should be sound on, please. Thank you. So, and last but not least, I want to mention the team that worked on this project over the last year and hand over to my colleague, Alexander Hildebrandt. Thank you.
Thank you, Elias, for your introduction. I want to show you the next project. Hopefully it appears. Okay, thank you. So we have created a completely new assistant. It's not a robot, it's not an animal, but it enables humans and machines to work together without any danger in a single team. So the main innovation lies in its compliance to contact. In the case of collision, the system natural compliance comes into play. Firstly, because the assistant is made of lightweight plastic, we will see this later. And secondly, because it is driven by compressed air and regulated by an intelligent control technology. And in the year 2010, we won the German Future Prize, the Deutsche Zukunftspreis. So how does it really function? The bionic handling assistant consists on 3 basic elements for our 3D movements, as well as a hand axis and a gripper with adaptive fingers. So the basic elements each comprise 3 arranged actuators. Each actuator is supplied by and with compressed air at the interfaces of the basic elements. Resetting is affected by the loop-like design of the actuator, which acts like a spring when the compressed air is discharged. Bowden cable potentiometers on the outside of the actuators gauge their extension and control the 3 position of the trunk. While in the hand axis, 3 further actuators are arranged around the ball joint. Special sensors capture the angular position of those. In total, the bionic handling assistant offers, in summary, 11 degrees of freedom. The adaptive gripper, I mentioned this before, named fin gripper, is based on the structure of a fish's fin. So the flexibility and compliance of the gripper, you will show and see this, are particularly impressive when it has to hold and move delicate objects or objects with different shapes. Well, the manufacturing requirements for our assistant were driven by the use of the modern technology of additive manufacturing. This morning we heard about the process, and it enables the production of individual moving system parts from polyamide, which is highly flexible and has a low density. At the start of this project, a production process, The material is in powder form and is applied to a building platform in thin layers. While a laser fuses each layer, new layer with a layer below and hardens only where the control program requires it. Any powder in the cavities is not hardened. You see this what happens and can therefore be removed later. And that's right now. Well, the compliance of the bionic handling assistant is defined by its construction, I mentioned this before, by the choice of the material, polyamide instead of metal, and by its control system. Direct contact between man and machine, whether intentional or not, therefore no longer represents a danger for humans. Even in the case of an electronic or control error, the new system remains safe due to its inherent compliance. In view of the advance of technology and the increasingly technological nature of our living environment, the non-hazardous nature of our assistant offers completely new perspectives for research into human technology cooperation. Until now, maybe you know this, conventional factory robots were carefully separated from humans. Safe and a direct contact now opens the door to new forms of interaction between humans and technology. The newest version of our trunk, which can be presented and seen at the outside, has a new interface for image and speech recognition. The system is now able to grasp objects without the need for programming or manual control. For this purpose, a small camera is implanted in the gripper module so that it can scan the working area, detect target objects, follow them, and issue the command to grasp them. For speech recognition, you know this by using, for example, an iPhone or something like that. We made use of the natural interface. Some commands, which can be spoken, of course, lead the trunk to grasp and to move objects. Well, the trunk can be used for industry and the home. This means that the system can also be used wherever humans need non-hazardous support from machines, for example, in medical technology and as an aid for the handicapped, as well as in agriculture, private homes, and educational institutes. In industrial environments, our bionic handling assistant can be used as a handling system to support assembly processes. During the further development of the assistant, we designed a compact version of the trunk, which was installed on the mobile learning system called Robotino. It allows the mobile robot to grip and transport objects. The robot can be moved flexibly, and the adaptive gripper can be aligned precisely by using a gamepad. So please turn the volume on.
Show me your workspace. Pick tool number 1. Open gripper. Go to home position. Pick tool number 2. Follow object 1. Go to home position.
So last but not least, thank you to our project team and thank you for listening. Thank you.
Thank you both very much. That was slightly scary. I think that's the last thing I'm going to see coming towards me before I die, is those fingers. One of the things that I've always liked about Festo are these new prototypes that we see every year, the flying things, the robot arms, and so on. I'm just wondering, we have a room full of hackers here, many of whom are probably very keen to have one of these to turn into killer robots. Do they remain industrial prototypes, or are there things that we can go out and buy? Will they be affordable in a few years' time? Can I have one for Christmas, please?
It's a good question. You're welcome for Christmas. Please visit me. But you're right. So we have installed our bionic learning network. My colleague, Mr. Knubben, mentioned this before. But we are a company, and that means we have to earn money, of course. And one product comes really from the bionic handling assistant. So this is one product. It's our fin gripper. It's like a fish fin. And what you really see is now, if I put there any force into the gripper, so it does not bend into the direction where the force comes, now it bends it again against those. And that is really a product. So that means we, can sell those for maybe for agriculture, robots or so.
Sure. But the whole arms and so on, and the bionic hands and things like that, as a single unit, will I be able to have one of those and link it to my laptop? Or?
We will sell them quite soon. The Robotino he showed in the end, the small robot with a small trunk on it. This is a product which we sell in our didactic company, especially for universities and schools and so on. And students are able or can learn programming with C#, for example, and LabVIEW and all kind of programming languages. And yes, we sell this since years already for around 4,000 euro. And now we combine this with the trunk. This will cost a little more. I don't know actually the price at the moment, but we sell it in the end of the year maybe.
So easily affordable for a couple of people getting together.
Yeah.
One final thing, all of your products over the past few years have been biomimetic. They've been inspired by nature. The trunk, the flying penguin, all of those different things. What's the next, what are we going to expect from you next year? Can you give us a little, what species are you going for? Is it lions? Is it horses? Is it amoebas? No. What's the next species we should invest heavily in?
Actually, this is a secret, I'm sorry. We always present this the very first time at the Hanover Fair, and we don't communicate it before what we are presenting. So, but what I can say, we will still, again, have something flying, like almost always. We have to do this almost because the customers want to see this and all the visitors. And we always try to find things in the field of industrial automation and process automation because these are our main competences.
But you won't tell us what's going to be coming out next year.
No, I won't.
Well, we'll let that be a secret. Gentlemen, thank you very much indeed.
Thank you.
And if everybody wants to grab you, you'll be around for the rest of the afternoon.
Yes. We are outside in the hall, have a small booth. You can come and we give a live demo if you're interested.
Fantastic. Ladies and gentlemen, the men from Festo.